We're going to be performing a mass balance on cells inside a batch reactor. So firstly, we're going to see the general equation for a mass balance. And the equation is that the rate of accumulation is equal to the rate in minus the rate out plus the rate generated. Now here is a diagram of a vessel. And on the left-hand side, we see that there is an input defined by Q in and concentration of cell in. Q in is a volumetric flow rate. It can be expressed in terms of a unit volume per unit time, so for example meters cubed per second. And the concentration in is the concentration of cells going in, and it's expressed as kilograms of cells per meter cubed. And multiplying the two together gives mass of cells per second. And on the other hand, on the other side, you have a volumetric flow rate going out, which is once again expressed in the same units as Q in, and the concentration of cells coming out, which is also expressed in terms of kilograms of cells per meter cubed. Now, for a batch reactor, we have a closed system. And what that means is that there is no flow going in and no flow going out. There is just a liquid or a fluid within a reactor, and something is happening in that fluid. Therefore, we can ignore the rate in, which is this term here, and the rate out, which is this term here, and we obtain the final equation, which is that the rate of accumulation
further down.
The rate of accumulation is equal to the rate generated. Now, this means that any new cell that appears within the batch reactor has to be generated within the reactor. Now we're going to try and express these two terms mathematically in order to have some sort of analysis of the system. And the rate of accumulation can be written as the change of concentration of cells, so concentration of cells times the volume, which would give the mass of cells, as the volume times the concentration of cells would give the mass of cells. So the change of the mass of cells by a change in unit time, dt. And that would be equal to the rate of generation. And the rate of generation can be expressed as the rate of growth of cells, which we will give an arbitrary symbol Rg, multiplied by the volume of fluid within the tank. Now Rg has units of kilograms per second. So at the end of the day, the units balance out. Now, in the case of a batch reactor, if we assume that the density remains constant, we can say that the volume doesn't change, so we can take the volume outside of the brackets to obtain V, change in concentration of cells, by change in time is equal to the rate of growth of the cells times the volume. Now, given that the two volumes are the same, we can essentially divide by the volume and make them disappear. So we would obtain the change in concentration of cells by the change in time is equal to the rate of growth of the cells.